Alrighty. Let's see. Looks like we're live. Hey everybody, FusionEd coming at you today, and welcome back to another live stream. This is going to be our weekly live stream, and we're just going to go over developer stuff. And if you're new to this series, welcome. And just to give you guys a quick rundown of what we're going to do as part of these live streams, think of these as like VR office hours. So basically what I mean by that is I'm going to be working on this project that we started last week, and you have a chance to like ask questions as I'm like doing it. But if you have your own questions about like projects you're working on or VR in general or anything like that, feel free to just shoot those out in the chat. I'm happy to answer them. And this is more just an opportunity for everyone in the community to learn. So with that, we're just gonna hop right into it, and we're just gonna quickly go over what we did last week, just kind of refresh our memories there, and after that, just hop right into it. So I'm gonna go ahead and start mirroring. So if you guys remember from last week, let me just pop the chat open, and yeah, we're streaming. Okay. Oh, actually, let me quickly double check, because I don't want to be talking to, yeah, we're good. So if you remember last week, this was our reference video, and basically the idea here is we're gonna use Google Cardboard to mirror our head movements, and then just have a bunch of different objects coming towards the mouth of our 3D model, and the idea is for the model to eat it basically. So I'm just gonna play a little bit of this. Here's some of the gameplay. And so yeah, you can see the food coming in, and like you have like this jiggle physics on the face, that is basically obstructing the food from actually entering your mouth. So last week, let me go ahead and pull up what we built last week.
Get the lobster. The lobster goes in. Grand and handy.
And we got that on our phones. Oops.
Panda. No. No! I want to
That's
eat the
awkward.
panda. Damn it! All I've ever wanted to do in life is eat a panda. How? There we go.
One more time.
I couldn't eat one before.
There we go.
I ate two in a row.
So let me pause that and make this big for you guys. But basically, using my phone, I can control where I'm looking, and that based on the physics of where I'm working and how the elephant rotates, the trunk is just using gravity and natural physics laws and just kind of wobbling around, and that's obstructing the mouth. So like if I turn the view a lot, we can open up the area to the mouth, and that's what we're going to be playing around with. So this week, what I kind of want to get to, and if we don't get, we'll see how far we get. But this week, trying to get to basically getting food spawning and headed towards that mouth, as well as adding some physics colliders to the elephant so that it'll actually hit the trunk instead of going around the trunk. So that it actually goes around the trunk instead of like going straight through the trunk as well as the face. So let me go ahead and put that to the side. And yeah, again, like if you have any questions about that or like what we did last time, shoot it in the chat. But other than that, I'm just gonna hop right into it. So first thing I'm gonna do is open up the project from last time. Since we've already worked on the project, it just pops up in Unity straight away as one of our recent folders. And this is where we left the project last time. Haven't changed anything. We still got that giant apple in there as well. And speaking of the fruits that we're basically gonna feed to the elephant, Abdo, who's the technical artist I'm working with, he has prepared some some 3D models of fruit, very low poly, and I'll put a link to that in the description below. So go ahead and download that if you want to play around with it. But we're going to use that instead of going through the asset store to actually find stuff. So let me go ahead and drag that in. So I have that in my downloads folder, I believe. Where did I leave it? Well, I might have to go download it. Let me go ahead and do that then, because oh, I have it in my Dropbox. There we go. Oops, the same thing as last week. So that's the Blender, but what we actually want to do is just open up our models folder, go to Dropbox, and drag that in. So there are the fruits, and let me just drag that into the scene for you guys so you can actually see what it looks like. So we have 4 fruits here. They're all bundled under one game object, which is fine. We're actually going to separate this out so that we can like send them individually. And the way we do that is through Unity's prefabs. So what we're going to do is create a folder, call it prefabs, and I'm just going to break all of these out. So when you drag a model into your scene, it like treats that as a prefab already. We're actually going to break that apart so that we can make each individual one our own prefab. Let me go ahead and do that. Oops, don't want to drag it underneath. There we go. So we got our nice 4 fruits. We're going to get rid of the top one. And we're just going to drag each of these down. Actually, no. Before I do that, I want to center these all at 0. So when you create a prefab, it stores the transform of where it was in the scene when you dragged and dropped it. I personally prefer that it stays at 0, 0, 0, but that's just a preference. So we can, yeah, let's replace carrot, tomato, pineapple. Awesome. So there we go. We have our four fruits sitting in our prefabs folder. So that basically sets us up to then go ahead and start writing the code for to spawn these fruits and send them towards our elephant. So I'm gonna go ahead and do that. I'm just gonna remove them from our scene. Also that one. And so there we go. We now have a clean slate for our elephant. And now what we're gonna do is we're gonna start writing some scripts. So what we want is basically we want a class or a script that controls like the fruits basically being sent towards the elephant. So what we're gonna do is just go ahead here, left click, create C# script, and we're gonna call this fruit spawn manager. Go ahead, create that. And I feel like I just opened up the wrong script, but that's okay. Yeah, I did. Any day now. Yeah, so let me go back to Unity. And I guess while I'm setting this up, if you have any questions, I guess as far as like the 3D model asset creation is concerned, Abdo should be in the chat with you guys. You can direct any of those questions to him. I know last time there were a couple questions on Unreal. He's also worked on that before, so if you have questions about that, like put them in the chat, and yeah, he can answer all of those for you as well. I mean, I'm also monitoring the chat as we go along. So one thing I'm going to do is, oops, I don't remember how to do this, where's the zoom? Because I know probably the code like last time, we didn't do that much coding last time, but last time was probably kind of small. So I'm going to just double check that it looks decent. Yeah, it looks, maybe make it a little bigger for you guys, just so you can actually see, because I feel like the code last time was kind of small. Cool. So first thing we're going to want to do is get an array of uh, all of the fruits that we want to spawn. Fruit. So like last time, basically whenever you create a script and you are declaring a public variable like this, what that's saying is in the inspector, which in Unity is usually on your right, in this inspector tab right here, that basically is saying that you should go ahead, when you add the script in here, let me see if there's a good example. Yeah, here we go. So for example, when we did the mirror rotation last time, when we declare a public variable, it gives us a reference for our script right here, and we can drag and drop basically anything that matches the parameters. If we do game object, that basically means that it's pretty much anything, because everything in Unity is treated as a game object. It's one of the higher level things, higher level classes. So that's our fruits, and what we're going to want to do is let's just go ahead and like get them spawning in a random place, and then we can start working on making them come from various locations. So to control time sort of actions, what you're going to want to do is create something that's in Unity is called a coroutine. It's basically, think of it kind of like a thread. If you're used to coding before, if you're not, basically what a thread is it's a process that runs separate from anything else. The difference with a coroutine though is, while like in theory you can kind of think of it like a thread, in reality a coroutine is actually running just along with your rendering code. So you don't want to put like anything too extensive in there, but for practical purposes, like if you just want an easy way to think about it, think of it as something that's running separate to the rest of your code, really. So the way you do that, I'm going to get rid of update here, is you use a return value called IEnumerator, which basically marks whatever method that you're using as a coroutine. I'm going to call this one spawn fruit, and close that. And before I forget, anytime you create a method like that's a coroutine, gonna want to go ahead and call start coroutine on it. So doing that, and doing this line right here, you're basically saying to start whatever this coroutine is and just let it go. So once we have our method spawn fruit, we can, what I'm going to do here is, because this is kind of an endless coroutine, it's going to do while true. And basically, this is a loop that we're saying we're just going to continually keep going in a loop until this condition is false. But since we're saying the condition is always true, it'll technically go indefinitely, at least until you kill the program, and then boom, it's over. But because this is a code routine, we have access to a new keyword within C# and Unity, and that's the yield keyword. So when you do, you basically say yield return, and this time in this statement we're gonna return wait for seconds. Oops. Let's just do 1 second here. So what this is saying is, at the completion of whatever code that we're going to put here, and this is basically, I'm just going to add a comment here. This is spawn fruit. Oops, I can't spell. What this is saying is we're going to spawn a fruit and then wait 1 second and then do that loop and do that process again over and over again. So how do we spawn a fruit? Well, so we have our reference here of, actually I should call this really fruit prefabs, not really fruits, because the difference between, I guess, the prefabs versus actual objects are prefabs, like they sit on your hard drive, whereas the fruit are actual game objects that are going to be in the scene. So I'm going to go ahead and actually spawn fruits. So the way we're going to do that is through a nice object called GameObject.instantiate. And initially, just to show you guys what this does, we're just going to initially do the first object in an array. So let's just test this code, because usually when you're doing VR development, you want to test small chunks really often. So let's go ahead and do that. And we're going to go ahead and create an empty game object, set it to 0 because I like having everything relative to 0. And I'm going to go ahead and, what are we going to call this? We're going to call this, call it exactly what it is, root spawn manager. Drag that in. And so because this prefabs is an array, we get the option of setting its size. I'm going to set it to 4 because we have 4 models, or 4 prefabs rather, and just drag each of these guys in. Alright, so save that, and let's just try it out. So again, like last time, this is using Google Cardboard, so that's what the game view is showing, is the cardboard view. And as you can see, if you're looking at the hierarchy here, and I'm just gonna, well, can't really see it that well unless I go inside the elephant. What you see basically is it's spawning a bunch of clones of that banana once every second, which is exactly what we want that script to be doing. So we've created a very basic spawner. Of course, it's not spawning in the place we want it to be, and the banana isn't doing anything. It's just kind of sitting there, being a little weird. Yeah, just being a little weird. That's okay. But it's doing what we want to do, which is always a step in the right direction. So I think the next step that we want to work on is choosing kind of a random fruit, which is actually really easy to do. We're going to go ahead and just do a like private. I'm going to go ahead and do private game object. Hold on. New private game object. And let's see, random fruit. And there we go. This is random fruit, and we're just going to go ahead and return a random prefab basically. Actually, we're gonna instantiate it. So we're gonna copy this line of code. No, actually, sorry, never mind. We're gonna random fruit prefab. It's probably the better way of going about this. And literally what we're gonna do here is just going to take that fruit prefabs line, instead of 0 like we did last time, and call the random class and go random.range. Go from 0 to fruit prefabs dot length. So that's going to get us the random fruit prefab. And what we can do is instantiate that here. And boom, that now we can go back to Unity and just kind of zoom in right here because that's where we're spawning our objects. And let's run it again. And boom, they're all like stacking up on top of each other. But if you look here at the hierarchy again, what you'll see is, you just kind of look down, pointing at the screen. You guys can't see where I'm pointing. But if you look at the hierarchy, you'll notice that it's the random 4 fruits that we added to our array. So there we have it. Very, very simple. And how many lines of code did we write here? Well, I didn't really have to make that a method, but let's just count. 1, 2, 3, 4, 5, 6. Let's call that 6. 6 or 7. However many you want to call that. But that's just very simple script to get things spawning in a random location. So now that we have that, now that we have them spawning, we want to actually spawn them at a location, and I'll also kind of have it randomized a little bit. So the instantiate method actually has, or instantiate function has a couple of different overrides. One of them being you can pass in the position and the rotation that you want your game object to hold, because every game object in Unity is associated, will always have a transform associated with it. So what we're going to do is we're going to write another method here, just to keep things clean, and call that private vector 3, call it random circular position. The reason I'm saying circular is because I think that's going to probably be what we want to do, is have it kind of what I'm envisioning. Let me go back into Unity here for you guys. But basically, we have the elephant here. I'm thinking this is kind of the way in the reference videos, like you notice that the fruits are coming from different directions. So I think it'd be useful, or like to simulate that basically, it's basically having some Z position away from the elephant, and having like a circle where objects can spawn from, or I guess a radius really, which is what we're going to program in. Keep that small. Grab some water real fast. And again, before I move on, feel free to literally ask anything, like about anything I'm doing. I know this is probably a bit more script intensive than last time, but that's just kind of part of game design, at least in Unity. So literally ask me about anything I'm doing, or also anything VR related, really. Happy to stop by and answer that. But continuing on, what we want to do is, I think probably the best way to do this is actually, so wherever this fruit spawn manager is, since it's associated with the game object, as you can see here, It's associated with the fruit spawn manager game object. We want to take, we can use its transform as a way to say where we want things to be spawning in a circle from. So we're going to go ahead and do that. So just to make things simple, super simple, we're just going to start with that, and we'll expand this method further on. But what we're doing here, we want to go ahead and do random circular position and then quaternion.identity. So now what this is saying is we're going to take a random fruit prefab and a random position. Of course, right now it's not random. It's specifically wherever our game object is. And then spawn it with this identity quaternion, which is basically saying the 0, 0, 0 rotation. So now that we have that, go ahead and run it. So as you can see here, it's spawning everything in that same 0, 0 location. But now if I go ahead and move this, it starts spawning them over here. If I go ahead and move this, it spawns them over here. Yeah, I can basically have it spawning wherever I want to. So we now have, well, I can move basically where the fruits are spawning from, so that now you guys can actually see where the fruits are coming from. I'm gonna go ahead and stop that. And so yeah, that's spawning the fruits. Now we can actually go ahead and change the position that we want these guys to actually be spawning from. So probably the best way of doing this is, so we want to take the Z position of wherever we place our spawn manager, and then we want to go ahead and put make a circle for the X and Y position, and then also maybe randomize the radius. So I'm going to go ahead and do that. So I'm going to quickly Google just the math for that circular rotation. So that's, in general, like, you don't usually have to do the math you want. You can derive it if you want, but you usually with Unity and all these popular game engines, it's some stuff that someone has encountered before. Which is, yep, there we go. Spawn prefabs in a circle. Exactly what we want. So, and I think, so all of this, so the two popular languages for implementing code in Unity are JavaScript and C#. And luckily here, someone has kindly translated the JavaScript answer into C#. So we can actually just go ahead and copy that and paste it into, of course, pasting. This is a bug with monodevelop. I don't know why it happens sometimes. Sometimes you just gotta close monodevelop and reopen it in order for copy paste to work. Don't know why that happens. Let's try that again. And of course it loses the zoom. What is it? Control plus plus. Nope, that doesn't seem to be working fine. Is it getting bigger? Yeah, it is. All right, should be big enough. And so now, yeah, so now we have this random circle, and it's coming to us as a vector 3. But let's go ahead and look at what exactly this code is doing. So first thing they're doing is just getting a random angle on their 360 circle. They create a temporary position variable, And then what they say is, whoops, there goes the light. I'm just gonna quickly, okay, motion sensitive lights. Actually, streaming from Stanford today, and so this is a new room for me, although I guess they are motion activated lights. So, what they're doing is you're given the center variable here, and they just take wherever in 3D space you want to put that center, um, plus whatever your radius is. And here's the little map that I can never remember for the life of me. Although like you can derive it actually pretty easily with pen and paper, but all they're doing is they do sine for the x, cosine for the y. So the sine of whatever random angle you've generated, converting that angle, of course, to radians, because that's what these functions take. And same deal for y. And z, because we're doing a circle instead of a sphere, we keep the z constant, exactly like what we want to do. So we could use this method, but I do, for game design purposes, we'll be playing around with the radius variable here, and having that vary from the center of our circle out. So it's kind of like, instead of just filling out the perimeter of that circle, we want, if this is our circle up here, we want to fill any place in the middle. So we're going to, I'm actually just going to go ahead and copy this, paste that here. No need to have a separate method entirely for that. So instead of center x, we're actually going to use, so the position here is actually we're going to call that transform.position. And this is just kind of to save typing. Yeah, just kind of to save typing. But what we're saying is we're going to take wherever our game object is, its position, and call that basically the center. And once we do that, we just have to fill in what our radius is. And for that, we're going to go ahead and create a variable called radius. And to create that filling effect, so it's not just on the perimeter of whatever a circle may be, I'm going to go ahead and do random.range. We'll go from 0f to a max variable. And for that, I'm actually going to create a constant, just so that we can play around with that in the future. Call that, const float max radius. So max radius, let's make that 10 for now. And drop that in. And so yeah, there we have it. Very simple, spawning in a circular position. And so again, just to quickly go over this, take the angle, random angle, set our center basically to be wherever our transform is, or wherever we place the object the script is attached to. Then we get a radius, and we offset the x and y position using a little bit of trigonometry and for circle math, and we set the z position to be exactly the same and return that. And so this method is then getting called when we instantiate the fruit, and we do that every 1 second. So we can go ahead and try that out right now. And let's go ahead and move our spawner out here. And so, which axis. Okay, I see. I moved it. So I'm moving it in the X direction, which is not exactly sure. So now if I move it in the Z direction, you'll see it doing kind of exactly that. Spawning in a random circle area right where my circle is floating. So it's anywhere about 10, I think that should be like 10 meters away from this point, anywhere in between. So yeah, I guess 10 is probably somewhere out here, maybe a little more. But yeah, and so I actually have my DK2 plugged in, um, and it's getting the rotation from that as well. I don't know. Okay, yeah. So we actually want to be spawning it in the other direction. Uh, I don't have the positional tracking plugged in, so that's actually causing the rotation to be so far off from where I want it to be, but that's okay. Um, as long as I mean, cardboard we don't have positional tracking either, so that's fine. And we have a lot of fruit. Wow, okay. I just noticed that the carrots kind of look like needles that are about to attack our poor little elephant. So sad. So sad. Actually, yeah, they're all kind of pointed towards the elephant, which is good. Um, grab some water. Cool. So that is pretty much what we want to do with our fruit spawn manager. It's very simple. Like honestly, like more than spawning the fruit, it was really um, making sure the math for like the location of the fruit that takes up the most amount of code. And that's probably uh, getting things positioned where you want is probably the trickiest part, especially in VR, because you want to make sure that you set distances that are relatively close to your camera so that you get a nice depth effect. And that's really crucial for VR. Probably arguably more so than in standard standard games, although like positioning there is like super important as well. So cool. So now that we have that set up, we are gonna go ahead and move towards. Let's see. Let's go ahead and get these fruit headed towards our elephant. So we're gonna do that. We are going to minimize that, and we're gonna create another. Um, I'm gonna create another script. And we'll call that basically fruit. And let's open that up. There we go. So actually, we may not even need this. Yeah, we may not need this actually. Let me minimize that. Because I just realized this is something we will want to do for the colliders anyway. So actually, for all of these, and probably the better way to do this is we're going to try and simulate everything with physics, just like we did the trunk. So what we're going to have to do that is add a rigid body. We're also going to want to add a mesh collider, and make these all convex because that helps with optimizations, and they are all convex objects, so that'll be good. And they all get associated with their own. If you're looking at this mesh parameter here, they're all getting associated with their own renderer. So that's fantastic. And once we do that, we have what we're going to want to do here. And this is the part. Looks like it's not here. That's unfortunate. What I was trying to do was if there was a velocity parameter on the rigid body that you could view through the inspector, we could have gone ahead and set that here without having to write any code, but that does not seem to be the case. So we're going to get rid of use gravity because we actually don't want these following gravity's gravity's order or gravity forces. Get rid of the angular drag, and yep, that should be that for the rigid body. And so now for all of these, yeah, let's go ahead and select all of these. I also want to add our fruit script, and just doing that now as opposed to later. Cool. So now we have the fruit script attached to it, and it's really right now the only thing we want to do is, well, yeah, there are two lines of code I want to write. So first is if I can remember the syntax for this. So require, yeah, no, I think require, no, require component, and then type of rigid body. So it's an optional, it's an optional line of code, but what it's basically saying is we want to require that whatever the script is attached to also has a rigid body. And that's important because we will be using that rigid body. So I'm going to create a reference to that rigid body, our body. And yep, so that's just our reference. And what we're gonna do here is call, right when the script starts, we are going to go ahead and get a reference to it from, well, when we call get component, it searches the object that we're currently on. There are a bunch of varieties of get component. But you can get it in children, you can get it from the parent, but this specific one, since we're requiring that there's a rigid body attached, we just want to get it from the current object. So I'm going to do that and put that in our body. And for our body, we want to just set its velocity to vector 3 dot forward. We can put 10 here for now, but it's generally nice to create some constants. What do I want to call this? This is a float. Let's see, speed. And this, as far as game design is concerned, we'll probably end up making this a random variable in the future. And we'll probably get to that hopefully today, but we'll see. Our body dot velocity, vector 3 forward, and speed. Cool. So that just sets its velocity, and that it should now, when we go back to Unity, gonna run that. Actually, let's do something real fast. Let's move our fruit spawner and permanently put it at. So where's our camera here? So camera is located at -10 in the z direction. Let's get these guys spawning from -20. So it's like behind you, coming from the circle behind me. If my eyes are looking here towards that elephant, they're coming from back here in some circle, and they'll be coming through me towards the elephant's mouth. Which we will also want to program in as well. Probably that's the next step. So let's just first go ahead and do that. And as you can see now, we've got all these fruits spawning towards the elephant. It's good at looking in the right direction. So that's coming there. But the one thing, so even though they're spawning, and I can see them spawning in that direction, they're not headed towards the mouth. And if we go back to that reference, they in general, let me pull that up. They're in general, yeah, you can even just see it from the still frame, is that they are, let me lower the volume here.
Burgers!
They're heading towards that mouth,
No!
but like obviously they don't
Almost
necessarily
finished. Ready?
all
Here we go.
get in.
Come on, so
So we're gonna wanna get a reference to basically where that that point is that we want to go to, and have the fruits kind of converge towards that. So how are we going to do that? Let me pop on this, and let's go ahead and not in cardboard, sorry. In our grouping, we have, that's the trunk bone. What I want to do is, actually we'll just create our own reference point and call that, I'll just create an empty, call it the mouth mouth target. I think that's probably a good way of going about that. And probably position that, looks about right. Probably just, yeah, looks about right. We'll put around that soon. But now that we have the mouth target, we need to get a reference to it on all our fruit. And if we notice, where is it? Here are the prefabs. Even though we can add a reference here, or we can get it dynamically. And I think getting it dynamically is probably the easiest way to do it. And I guess by dynamically is what I mean. It's not really dynamically. I should rephrase that. What I mean is basically making sure that you have a reference in a consistent place and being able to access that all the time. So one of the easiest ways to do that is if you have a game manager. So in this case, we can probably use the fruit spawner. We might want to move it in the future, but to like some sort of scoring manager of some kind. But for now, we're just building up slowly. We'll just put it on our fruit spawn manager. And so we have that script reference here. I'm going to go ahead and add another public variable. Call that call it a game object. And this is called, let's call it mouth. Yeah, let's just call it exactly what it is, mouth target. So we have that public variable here. Oops. And so now that should open up. Yeah, there we go. Once it compiled. And we're just going to go ahead and drag our mouth target towards that. So now we know the position in absolute space. Oh wait, one thing is we gotta also make sure this mouth target is under the elephant, because from last time what we did was we added the mirror rotation on the elephant object, not this grouping object, so that we can get that nice swaying of the trunk. So we want to make sure that the target actually is moving. Actually, do we want that? Yeah. We'll take a look at how it looks. But we actually may not want that now that I think about it. It could be actually a good idea to just have it coming to a consistent place. But this is all part of experimentation. Now that we have our mouth target here, so how are we going to access that from the fruits class? Um, this is now kind of getting into something I think it was called singleton programming. It's really nice technique, especially in Unity, where it's kind of hard to actually you write a lot of scripts, but you don't have a good way of actually getting them to interface with one another. So to that end, I'm gonna go ahead and create a um, a singleton. What that means is, I'm just writing the code up right now, but what that means is you basically, when you create a class, oops, this has got to be static. You create a static variable that is the same as that class. It's called an instance. And what you basically have to declare is that it is going to be the only instance of that class in existence, which is why you make it static. Static basically says like it exists regardless of whether there are any actual objects, which is from object-oriented programming. Um, so this is basically saying um, if, so we're going to just quickly just type up that code. Instance equals this. So void awake is a method that's called before start. So if you want to get timing down, just think I put anything that everyone else needs to know in awake, and then put the rest of my code in start. So ever since we want the instance to be set up just like basically like that, we put that in awake. So what this is saying here is if instance equals null, which means there's never been an instance in existence before, we want instance to now be whatever we're creating at this moment. So that's that. I'm not going to add it here, but what you can do is add an else clause that deletes the current object as well. And then just for consistency, because these are the type of bugs that can eat you in the butt if you don't actually pay attention to them. What we want to say is when we destroy this class, we've got to make sure if we are the instance, we want to reset instance to null. That way something else can spawn up in the future. So that's awake, that's destroy. And so now once we've done this, we get this really neat feature that we can say, we can get a reference to it. So instead of vector forward, we want to say vector3 dot direction equals fruit spawn manager dot instance. So that gets our single instance. Mouth target. So that's the target. And we're just going to go ahead and subtract our position. So that's saying here's our target, here is where we are right now, and we're gonna have a vector that points directly toward that. And we are going to normalize that so that we can get a velocity. And hopefully, I think I got the direction right. Otherwise, we're gonna just have to flip it. We want unity, and let's go ahead. And I have compiler errors. Minus. Oh, so mouth target is a game object. We want to do its position. That's what was complaining there before. Let's get that running. And that does not look like they're headed towards the mouth. Actually, no, it is. Oh, okay, this is. So what's happening here is you can probably see it better if I slow the speed down. As basically what's happening here is we set the velocity to be right. So it is going in the right direction, but it's not. Yeah. So yeah, for example, it's going in the right direction, but it's not going. Um, it's not going, I guess, there sharply enough is what's happening. So actually, wait, is that right? Should that one's going right? So like that one. I'm wondering, huh? It all looks like they're going in the right direction, but I would have figured that they go more sharply. So this is interesting. I was not expecting this. Um, hmm. So what we could do, so there are a couple options. Is one, instead of using the velocity, you can use the lerping function to move it, but that unfortunately does not simulate physics. Um, let's see, did I miss a reference? So that could potentially happen. The fruit spawn manager. Oops. That is that mouth target, which is right there. And let's see. Okay. So we have that. Let me play it again just to make sure. Maybe get them going a bit faster also. Let's see. Just so that we can actually see what's going on in this debugging. So they're coming from there. And what happens? Because they should all be converging. Oh, did I? Yep, okay. That was the problem. This is classic. We didn't set the velocity towards the actual direction. We kept it as vector forward 3. That is classic debugging right there. So now let's see that if they actually do what exactly we want. Yep, perfect. Yeah, that one. It looks a little wonky for some of them, but that's also because it's going a little too fast. But now, as you can see, the velocity is set properly. It's going from their position to the end goal of that mouth, regardless of where it starts. So there we have it. So note to self: make sure that when you introduce something new, you change all your references. Usually a good start. Sweet. Now that we have that, we can actually now start playing around with some settings, which that's where the game design parts really start to come into play, especially with VR. So one thing you generally want to focus on, especially with VR games and your lower end systems like Gear VR or Cardboard, is you got to be really careful about how fast things are moving around you. Um, because the more movement that the user potentially feels, and the more activity that the user feels, it can potentially cause them to get sick, especially when you're talking about lower end systems like mobile VR. where you don't necessarily have the full resolutions and specs required to actually um, to, to, to soften the blow of these behaviors. So how do we go about solving that, I guess? Or rather playing around with that, not solving it. What we can do is, instead of making it a constant, yeah, okay. Instead of making it a constant here, what we can do is, still not keep it a constant, but we can actually go ahead and, instead of putting it on the fruit variable, we can put it on the fruit spawn manager. The benefit of doing that here is it's accessible to all of the fruits that we're spawning. And let's just go ahead and copy that and do speed. I don't like it being lowercase. We're going to make this uppercase. And the reason you know of it as a constant is so that you can change it in the inspector so that you can play around with it. And I just changed the name of it, so there we go. So now, if we want to actually play around with it and see what it's like in VR, there we go. I'm gonna have to do that. Oh, that's actually wonky. I left the cardboard in, but that's okay. Actually, yeah, this is a little wonky because I left the cardboard in as opposed to the riffs rendering. So we're gonna switch that out actually. Do that. Cool. So, okay. So, one thing I'm noticing right away is the fruit look appropriately sized, which is good, but them, so I can look at the fruit coming towards me. So they look appropriately sized for the elephant, but they are a little big once they're like coming through me. So we might want to try and avoid, them actually like coming through me. We might want them like going around me, but not necessarily through me. So we'll have to fix that. Speed seems to be fine. Yeah, that's some of the things I just like noticed right away. Oh, I guess the other thing that I notice it now is obviously like once they get past the elephant, we're gonna want to delete them. So we're gonna just have to find some Z point that is pretty far away, probably like, I don't know, 50 meters or so. We can go ahead and just call a delete function on them. So let's go ahead and trying to think what we should do first here is take some water. Let's go ahead and let's first do the delete. That's probably the easiest thing to do. So we're gonna just use the update function here. So let's actually start running it again. And basically get it to get it looking at the elephant, and once we do that, we can, I don't know, take a look at this banana here. Take a look at its z direction. It's like 90. We can say when it crosses like 70 and the z, we just want to go ahead and delete it. Obviously, you can do a lot more fancier stuff, like basically fading it out or shrinking it to reduce like the stark disappearance, which we can we can do potentially later when we're like polishing, but just to kind of get the game mechs down, let's just kind of go ahead and do this fast prototyping. So what we want to say is if transform.position.z is greater than 70. And let's also make that a constant. Public const float disappear length, I guess, equals 70f. Go ahead and do that. Do that. Transform.position.z greater than disappear length. Perfect. So once we do that, gonna want to go ahead and basically say this dot let's destroy game object. Oh yeah, sorry. Game object dot destroy. I should call it. It's a static method, and this dot game object. And we can. There's another override where you can pass in how much time after the method is called for it to destroy, but we can just destroy it immediately. So basically, now we have update and we have start. So we can go ahead and run it and just make sure it's working. Fit. So I think 70 is like around here. So let's just watch that tomato. It's at 30, 40. Yep. Pops at 70. Perfect. So yeah, so like that's kind of like the plane where things disappear. And you always gotta make sure you're like deleting game objects, especially the ones that you're not using. It's not only optimization for cardboard, but like any game development as well. Just because it's actually it costs extra render cycles, like the more objects you actually have in the scene. So you don't wanna like spam the scene with like too much stuff. But there we go. And 70 actually might be an extreme, really far out, because that's 80 meters away from the camera, which is still pretty far out. And yeah, so that's destroying. Now, as far as instantiating is concerned, so previously before, we picked random range from 0 to max radius. So having it very close to you, it'll come through you, which is it's a really weird effect. We're probably actually going to want to have a min radius in there, and we'll set that as like 2f and call it min. Copy that, paste it there, and boom. Random.range. So now it's going from min to max. So let's just try that out. That should have been really easy fix to get things spawning. And so yeah, looking at it until there's everything. Why is everything? Yeah, like that's like a little below me, so it looks actually pretty good. It looks like these. I didn't get a chance to look at the models beforehand, but it looks like these fruit are about like 1 meter or 2 meters wide, which is huge. But we're gonna ignore that for now, because this is a low poly cartoony game. So whatever size works. Yeah, awesome. And that's that part. So let's see, nothing in the chat, so we're good. So yeah, so we got the basics of for adding fruit to our game. Sweet. So let's just actually, while we're at this point, which is actually a pretty good point, let's go ahead and get that onto cardboard and see how that looks. Things we're gonna, because we're using the DK2 to test, like we did last time, we want to go ahead and switch it back to cardboard. So we'll go ahead and take out the main camera, add in the cardboard main camera, and go to player settings, make sure virtual reality is supported off. Again, really hoping that the cardboard team or the Unity and cardboard team make cardboard a native support in the future. We'll see how that works. And because all of the settings are the same from last time, we can go ahead and click build and run. And we're going to call this v3. Again, like all these test files, we can just keep saving just so that we have references. And that's that part. And yeah, I know like this part is a little code heavy, unlike last time, but that's just kind of part of game design. Hopefully, I think next week I'm going to try and focus a bit more on UI and audio. So those should be a lot more fun to play around with. And let me know in the chat or comments what else you would like to see. Just helps me gauge kind of what is the most effective for you guys. I'm just gonna make this big. That might be a little too big, but okay. So again, we want to test in cardboard just to make sure, but yeah, this looks good. Frame rate is actually a little, actually no, it's fine. It's notice it a little bit, but that just might be I'm like spawning too many fruit or like not getting rid of them fast enough. Like I notice it if I like turn my head up a bit, like it looks a little blurry. But like hopefully you're not like moving your head all around that much. So like we can, but yeah, as far as like the game is concerned, like once we add the colliders in there, like, and probably slow the fruit down a lot, because like this seems to be happening way too fast. Maybe make the fruit a little smaller, but yeah, we have it on cardboard. That's so cool. This is actually, like, granted it's like a very simple game, but I think it's like doing the job pretty well. And yeah, that's awesome. Making progress. That's what I like to see. Alright, sweet. So I think at this point, so we're about an hour in. We're going to take a quick 5-minute break and go over, actually, instead of some code, just kind of go over a couple apps, cardboard apps that I saw over the course of the week. Because I think more than learning by doing, or actually no, equally learning by doing, I think doing includes like seeing what others have built and learning from that. So with that, I'm gonna spend like maybe 5 minutes, go over a quick. I wanna show you guys something I think is really cool. It's helped me before. I used a Gear VR version, but I think the cardboard version is equally cool. I want to go over quickly virtual speech, and then we're gonna go ahead and add the colliders in so that you can see the fruit like going around it, and then hopefully add a scoring mechanic of like when it hits the mouth, then boom, we get points. If it goes around, then we don't get anything or potentially lose points. I don't know. In the game that was built previously, you don't lose anything if you miss a random object. we can play around with it. I don't know. I still really want to try out that game, but unfortunately, for whatever reason, I can't download it. Um, so let's go ahead and jump into virtual speech. I think that's a let's max out the volume here. Um, this one looked like a really nicely cardboard version. So if you don't have a gear, or I think there's a version of public speech uh, for the DK or for the Oculus. I don't think for the Vive, but I'm pretty sure for Oculus there is one. Might have to use a lower runtime. I'm just going to jump into this. I think we can select by tapping using V2 cardboard. So this has the conductive foam. So the thing I really liked about this is, one, you can customize the slide deck here, and this one's actually, I think it's because I'm mirroring, it might be a little laggy, but that's fine. So you get your custom slide deck there. You got a timer, and all of those are cool. So when you're like practicing stuff, like I was practicing a pitch the other day, and like it definitely having like this stuff and not having to manage it is really useful. But the nice thing here, as compared to the Gear VR one, is they're using actual human images and animating them. But the one thing, and I'm not sure if you can see this from the YouTube video, but the really interesting thing that I found is, if you look at the humans that they're using, they're not 3D models, unlike other public speech simulators that I've used. And yet, even though they're not 3D models, they're actually just 2D images that are animated. They still feel pretty realistic. And I don't believe that they're using any 3D tricks where it's a 2D image actually, but like they slightly shift it for the left and right eye, so you get a 3D effect. These are just like flat 2D images. And I found that really cool because like you still feel that they're real and like in that world, even though I don't actually have any depth perception of them. Um, and that's legit. Like it just kind of goes to show that even if you're not a 3D modeler, but if you're like a 2D artist or and you want to get into VR, like an easy way to do this is actually just kind of like plopping 2D images into a 3D world. So there was actually it was at the GDC VR Mixer uh, last week, or sorry, this was like probably a month ago actually. And oops, I just realized of how tiny this is. Let's max this out again. Um, and I tried this one demo, and it was just like they were just using storytelling. They had like a 3D world created, but like all of the characters in that world were just like these guys. They were just like flat 2D images, but like they're positioned, of course, in the 3D world, and yet it still felt pretty real. So it's like pretty powerful that like even um, just normal images and virtual reality is still a very viable thing to create. So I'm just gonna quickly go through this interview. I usually do engineering interviews. I'm gonna try human resources. I have no idea how this is gonna go. And the neat part about this is like this is like simulating an interview. So uh, I get asked questions. I have no idea what these questions are actually. Human resources. That is a fantastic question. I actually have no idea who I'm working for and what human resources help I'm doing. So yeah, that's the reason why I chose that.
How would you go about hiring a new technical employee for us?
Wait, that's my job as human. Oh man, I'm already failing this. I don't know really what human resources does, to be perfectly honest. Coming from an engineering background, I like usually I'm used to like talking to managers, very rarely human resources. Oh man, I am failing this interview. I don't know where here is. I feel like, where am I, honestly? Uh, I really don't know where I am. Okay. Well, that like just kind of gives you the gist of like what this thing does. But like hopefully it was useful to like kind of see what other people were doing with the way they create their environments. And that's something probably in the future I kind of want to go a bit more into is like how do you actually go ahead and like create these stories, especially with cardboard, but really virtual reality in general. Um, but I think that's enough playing around there. So we have about 40 or so minutes. We're going to go ahead and attempt to get through the collider physics and finish up the game. Whoops. The game design. Um, Drag that off to the side. But all right. So let's for the last 40 minutes, I'm gonna go ahead and try to do some quick physics here. So because this is a rigged object in Unity, it comes out actually as a where does it show me that? Comes out as a bunch of skin method. Here we go. Comes out as a skin mesh renderer. So that's slightly different from the fruit. Let's pull that open. So for the fruit, these guys come out as mesh renderers, and that's because they're not rigged. With skin mesh renderers, actually, and I guess because they're not rigged, you can actually use Unity's built-in mesh collider to get a nice mesh surrounding it. But for skin mesh renderers, um, they Unity doesn't provide you the ability to actually use the mesh renders like the fruit, and that's because skin mesh renderers can deform a lot. As you can see with the trunk, it like deforms and shakes around, or like we programmed it to shake around very freely. And to actually wrap a nice mesh around our elephant here, you would actually need to be updating the mesh every frame, which is potentially costly, which is why they don't support it. We're gonna first try to use a little hack that I saw online to see if we can whoops, there we go. Create see what the performance cost of actually updating that mesh is every frame. Um, but if it looks very costly, which is what they are claiming in the forums that I'm reading. So here was the post that I read. Um, so there we go. So this is actually the code that we want to use for the skin to update the collider. So if you actually like read through these posts, you'll notice like this post here. You wouldn't want the mesh collider to update with a skin mesh, even if it was possible, since it would be very slow. You can attach primitive colliders to the bone. So this is the solution we're probably going to want to use. Yeah, that's probably the solution we want to use. But I do like some people are saying like if it's like low poly enough, which ours is, it might not be that bad to just go ahead and update the collider. So we're gonna try and do that, test and see if it runs well on cardboard, and if it doesn't, we'll go ahead and add the primitives in. So what we're gonna do for that is, so this is the actual like mesh that we want to update for. So we're gonna have to create another script here. We'll call this update skinned mesh. So let's open that up within MonoDevelop. Perfect. We have it nice and big as well. And let's see. Let's copy and paste this stuff. It's here we go. I can't copy for the life of me. What did I copy? copy. Oh, great. Just not even remembering what I copied. Let's try this again. God. Maybe I should actually start using Visual Studios. Might be a better choice for the future. Even though, I mean, I find monodevelop usually fine, but I don't know, recently, or at least in the stream, we've had to like update it twice, which is weird. Okay, so this is our update skin mesh class, and I'm gonna make those private. So let's quickly take a look at what they're doing. So they first create a brand new mesh, then they go ahead and say we want to bake that mesh into, what is mesh render? Our skin mesh render. Or sorry, we want to take our skin mesh render and bake that mesh into the new collider that we made. We set the shared mesh property to null just to clean it out, and then we reset it. To be honest, I'm not really sure if you need this line. We can play around with it, but yeah, we'll play around with it and see. We want, so what I want to do is, I want the start method. I'm going to actually want to call update collider every frame, so we'll also want the update method. And I know I deleted them, but we can always put them back. I'm just going to call update collider every frame, and so that's all we need to do an update. And then for we're actually going to make these public. I was initially going to say that we should make them private, but let's make them public. So public. We don't actually need to start then. And go to Unity. I'm gonna add a mesh collider to here. So it doesn't know what the mesh is. We're gonna make this convex. And we're also gonna add our copy pasted update script. So let's add the mesh collider and the skin mesh render that we want to use, and just run it. So there we have it. So on my laptop, it's actually not running that badly. And so now you can actually see the physics kind of playing around with it, right? So, which is actually really cool. There's a couple of things I want to point out. So, even though we are baking the mesh, there is one issue that the mouth is always hidden. It's not actually forming to the whole mesh, which will actually prove to be a problem, because that means that these fruit can never actually hit the mouth, even though we have the truncate here. What we ideally would have wanted to have happen is for this mesh actually to run smoothly up the trunk and down here, so that we could use it. But that doesn't seem to be the case. Another thing we want to, but this is still a good test, because what it shows us here is that the fruit are they keep spawning and spawning, and the reason for that is they are not, unlike last time where they were, after they get to like 70 feet out, 70 meters out, we could have them delete. Now as they like brush off against the elephant, they lose momentum and they start flying all over the place. Most of them not even really getting to -70 in the z direction. Very few, if at all any. These guys might be getting there, but the rest aren't. So we need to fix that. But now we know this is probably not the right way to go about it. So we're gonna close that, and instead of this mesh collider, we're gonna get rid of that. We're also gonna get rid of the update. So now that we know that, we will actually want to go ahead and see where are the hinges that we added. Just these guys. Cool. Yeah. So these are from last time. These are the bones that we rigged. They're the hinge joints, and so what we're gonna do is, including actually this one out here, but we're gonna add a what type of colliders do we have? So we have a box collider with capsule collider, a mesh collider, which we can't use, a sphere collider, and we can't use a terrain collider. So let's go ahead and use capsule collider because that should make things interesting. So I'm gonna go ahead and actually add them to anything that we add a hinge joint to. So that looks to be these guys. Let's go ahead and add capsule collider. Where's that little dude? Wait, what? Interesting. I don't know why it's okay. So that looks right. So that actually covers most of the mouth. Yeah. So I believe. So we're gonna want to make. I don't remember if that bone. Can't remember if that bone has, or the bottom has a bone associated with it. Let me just double check that for you guys. No, it doesn't look like it. Okay, so that's the bottom most bone. So to make sure it actually like hits the whole part of this trunk, we are gonna make the height 2. Nope. I'm gonna make it's on the z-axis. No, on the x-axis. The x-axis, we want to make the height 2, and I'm going to drop this by -1, no, -0.5. Looks reasonable. Maybe make the radius 0.2, nah, 0.5 was good. We can be a little approximate here. And so that covers this bottom part of the trunk. For this, this is actually tricky to look at. I think that covers it honestly pretty well. Same with that one, we can make probably a little bit bigger. Again, in the in the with the radius, actually make this 0.75 because that part of the trunk is a little bit bigger. That actually should do it as far as the trunk is concerned. So now if we can go ahead and play that just to see what the collider does. And yeah, just kind of bounces off, as you can see, if it hits the trunk. Now, yep, that last one, it went through, right? Not pretty, not super pretty, but it does go through. There are a couple of things we noticed, right? So in the previous video, the one thing that they do always is they always have a force going towards the mouth. So here they kind of bounce off and then we never see them again. Whereas in that video, there's always some force. You're blocking the capsule collider. Oh, whoops. Thank you for telling me that. So let's see. Let me open this up. Got it. Let's see if I can move this for you guys. Let's see. Move it? No? There we go. Little janky hacks. Move myself to the top. Hopefully you guys can see the capsule collider now. Let me know if that helps you guys. So hopefully you guys can see this part. I'm probably blocking the transform now. Move it back down probably in a little bit, but yeah, unfortunately Unity doesn't really let you scroll here to move up the capsule collider. But yeah, so the things, just to kind of quickly go over what I did. So you have bone 004, that's like the bottommost bone in our window, and changed the height to be 2, and then moved it up a little bit to really match the full bottom of the trunk. Also had to change the x-axis direction so that the height actually went up as opposed to the y or z-axis. Here, I kept it the same, and for the topmost collider, I made it 0.75 in the radius. So just because this part of the trunk is a little bit bigger. So thanks for pointing that out, Chicken Bacon. And with that, yeah. So now, we have a couple of options of what we can do. So obviously, we want to change the fruit to be keep on like have a small force, whatever that may be, to like push them towards the actual mouth or like in the Z direction. But I think the first thing that I want to do is have a collider here in the mouth itself, so that whenever it hits this collider, that's when we know we've basically hit the mouth. And I want to just delete the fruit whenever it does that, as well as probably play a small animation. So hopefully I can get to that in 20 minutes. So to do that, again, we're going to want to add a box slider, and I know now I'm going to totally be blocking it, so move myself back down again. And so yeah, I'm going to add a small box slider. Well, that one's a really big box slider, but does it get hit? Doesn't look like it gets hit, so might make it a little bit bigger in the Y direction. Let me move it down like move it down 0.25. Yeah, that about does it. So that's good. So now that we have a nice box collider right there, let's go ahead and add a tag to it. So this is the first time we're touching tags, but tags are basically a way for you to add a little check to each game object, so that when you're in the code, you can actually go ahead and check if a game object's tag matches a certain string. It really works well, I guess, if you have multiple objects of a certain tag. For this case, tags might be overkill since we know that there's only one mouth target, but we're going to do it anyways because we can. Yeah, perfect. Have the mouth tag. I'm going to pop up in the chat again. Oops, not that. Back to Unity. Cool. So now, when we're I have to look at the code for this again. So with a box collider, we wanna we're basically going to have to use the trigger methods for colliders. What that means is whenever two colliders intersect, we want to basically check that they we want an event to trigger within our scripts that basically allows us to know when that event occurs. So, and it's also important to make sure that if you're using mesh colliders, like we are here, actually we're gonna have to turn is trigger on in all of these. But the thing we want to notice is if you're using mesh colliders, you got to make sure that your colliders are convex. And depending on the direction of, like if say for example, if the mouth was moving towards the fruit, then we definitely want is trigger on here. But since the fruit are moving towards the mouth, we actually don't really need this is trigger, but I'm gonna put it there anyway. It's generally if you're not sure about which direction things are gonna happen in, it's probably best to put is trigger on both potential objects that could cause the trigger. Let's go ahead and open this guy. And so we're going to want to do Unity trigger event. Google that. Go here. Nope, not this. We want on enter trigger. Just make sure I get the correct method. Yeah, this guy. Perfect. No, I want this in C#. C# is a lot more friendly. So we're just gonna copy this little guy here and add that to our fruit script. So you gotta make sure that the method name is exactly this on trigger enter. You can optionally pass in the collider object. We're actually gonna need it in order to get the game object that we want. But if you just want to check in general if something enters a trigger, you don't actually need this. But yeah, we do here. So go ahead and do on trigger enter collider other.gameObject. And now we're gonna want to check the tag and make sure that it is mouth. So if other.gameObject.tag equals mouth, so let's just make sure it's working and just do a destroy this game object. Let's see how that works. Oops, compiler can't implicitly convert type string to bool. Oh, the classic forget your double equals. All right, so now we got that trunk swinging around, and it looks like, well, interesting. Let me make sure. I do have my capsule colliders on here. I'm wondering. So it seems like it's actually ignoring it now. And I'm wondering if it's because it just like it's checking. So let me go ahead and on these guys, remove the is trigger function. Because now it's actually just completely, yep, there we go. Yep, perfect. So note to self now, if you put the is trigger on the fruits, it's going to treat it exactly like a trigger and ignore kind of the physics properties that we want, which is not a good thing because we want it to use the physics. I don't have rotation set up because we're on cardboard. But But yeah, we've got the destroy. We've got 15 minutes now. Kind of want to keep this towards 2 hours. Um, but let's actually go ahead and let's just write up. Let's do an animation for the mouth. Like whenever it hits the mouth, it's gonna close. Maybe I don't remember if this is rigged so that I can do a nice little chew, but we'll see if we can. And so the way you want to do that is using Unity's animation. And this is a pretty neat tool. I really like this. I didn't discover it until recently. Uh, but if you want to do some like quick animations with even like super simple stuff, this is the way to go about it. So I believe so. The mouth is rigged right here. So we're just going to play around with that real fast. Yep. So well, we can do. We basically want this animation to play. A nice chomp, 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 chomp. Just leave it about there. Actually, yeah, that's good. So to do that, all we need to do is go here and create an animation. I like to put them. I like to separate my folders a lot, so I'm gonna go ahead and create a animation folder. That's gonna go ahead and create animations, and we're gonna call this chewing. Let's save that. So what we want to do is actually go and add rotation. So that creates, so if you're new to animation, the way it basically works is you get a timeline, and so you can set how many frames you want to have in that time frame, and you get a time scale. So initially, it always sets it for about 1 second, which is actually pretty good. But you can go a lot longer, you can go a lot shorter, whatever you're feeling really. One thing I don't know how to do is actually like scroll left and right on this timeline. Just gets kind of annoying sometimes. That's minor detail. So for this, we can keep it at 60 frames per second, and I think this chewing animation we want to happen. I don't think we want it at like 1 second. We probably want it closer. Guessing 2.5 seconds. Think should be reasonable. May or not be reasonable. I don't know. And so as soon as he eats, probably after 40 seconds, we're gonna want the mouth to close, maybe fully, something like that. Maybe around 120, opens partially, maybe 2 minutes, back fully closed again. That might be, you might want to shrink this down, move these, I don't know, 25 seconds, 50 seconds. Yeah, maybe you want this happening a lot faster. 110 and 130. And then I guess the last thing it's got to do is just come back to where it began. Can I copy these? Just want to copy those frames. Let's see how that looks. So just play. Yeah. So we can make it faster. Yeah, let's definitely make that. Oh, it seems really slow. Might want to duplicate the chewing a bit more. 35 maybe. This is all just like artistic look on it. Let's let's still keep it at 2 seconds, but so I mean obviously like if you guys know or have a better sense of what you want to see with chewing, you guys can definitely change that up however you guys want. But I'm just gonna add in some frames here. Move this about somewhat evenly spaced. Alright, so let's see this. Let's see, where does it start? It starts there. Okay, so where does 0? So it's at 46,692. Okay, I'm going way too far. 46,692. This is basically 0 and 0. So now let's, yeah. So boom, we have an animation. Now we obviously want, basically this, the collider to kind of disappear during that time. So the way we're going to do that is, believe, ooh. Okay, so this is actually going to be a bit more tricky because collider is actually on this mouth target. So we're moving. So one thing we might want to do is instead of just having the mouth target attach the elephant, we might probably want to attach it to the bone. And that way, so not only do we get access to the mouth collider while it's animating, we also it'll also move with the mouth, so it'll be a bit more realistic. So we can go down here, click on box collider, click on size. We want the size. We don't need position. I don't know why that's there. And boom. So now we can change the size over time. So probably so here. Yeah, here. Here we want it at 1, but the next frame over, let's get it down to. Let's get it down to, or sorry, maybe here is more appropriate. Delete that. At that point, maybe get it down to like 0.1. Okay, or yeah, no, let's get it down to 0. To 0. And then here, yeah, here looks good. So, oh, okay. So we gotta make sure that at all of these points it stays 0. Oops. Oh man, I can't click. You make you 0, and you make you 0, 0, 0. Perfect. All right, there we go. Now we have a nice little chewing animation. And so, so basically the reason we're closing the collider there is so that when other food comes by, not that I really think it will because the trunk should be blocking it at that point, but when other food does come by, nothing really hits the collider. And actually, probably the better way, instead of just like closing it, would actually be to disable it, now that I think about it. But this works too. So great, now we have that. If we go now, so that it's a looping animation. So we're gonna so the one thing, I'm not sure if I like this or not that Unity does this, but for all of your animations that you use with the animator, the animations tab, it automatically loops them. But this is an animation we don't want to loop, so we're just gonna disable that. Save that here. So that animator is now attached specifically to that bone. which is fine. And yeah, now we have a mouth, the collider. We just now need to know whenever whenever we get the fruit to hit our collider, we need to just trigger this animation. So to do that, what we're gonna do is once we've created the animation, we now have a let me actually pop this out a little bit. Um, Scroll, can I scroll? I can't scroll, that sucks. Can't scroll easily. Come on, buddy. It's not today. Yeah. I think you move with the scrolling wheel, but I can't seem to do that right now. Alright, well, we don't need it. So we can control the animations with the another file, and this is the actual way you control animations with an animator. And that's the tab we have open here. And so we're gonna have to make a transition to exit. But the way we basically control it from our scripts is we create parameters. And oops, better. The way you add, it's really simple. You just go ahead, go to parameters, click Boolean. Sorry, not Boolean, trigger. Trigger. Let's call this start chewing. And so basically, whenever that start chewing is called, we now just want to go ahead. Let's shrink this a little bit. All right. Okay, perfect. So whenever where's that transition? Defaults to that. Oh, whoops. Okay, this is actually a little nuance. But fine, we can do it. So actually, what's really happening here is, so this yellow that you're seeing, that is basically going from the start of the animation. It's saying we're gonna just default to going to chewing, which is not what we want to do. We actually want to have chewing happen naturally. So what we have to do is create a state that's just an empty state that does literally nothing, and make that the default. So we're gonna call that the default. And so again, yeah, there's like a start button, just like there's an exit button. I'm gonna go ahead and make a transition from empty to chewing, and we do that. And so now if we go in the inspector, we see that we see we see the options for that transition, and you can add conditions, and this is what we want to use our parameter start chewing. So we're just going to go ahead and add, and since we only have one parameter, it just kind of defaults to start chewing. And so whenever start chewing is called or set via script, we're going to get to start chewing, and then it'll immediately go to exit and get back into our empty. So let's just see that in action. So now it's just kind of waiting in empty, and when we click it, it does our chewing animation. So let's we can view that again now in the scene view with us actually looking at it. Again, does our chewing, and then opens up. Sweet. The one thing we want to be a little careful of is the fact that empty, so it is looping here. We want to set the speed to actually be really high so that one, it's not like stalling every time we want to chew. And two, I believe there is an option somewhere. I believe there was an option to stop looping. I can't seem to remember where it is. I think maybe it was solo. That doesn't look right. But yeah, as you can see here, I mean it's looping here. I'm gonna have to look up how to make it just stop. I can't remember it off the top of my head. Um, but because it's going so fast, like as soon as we get that trigger, it just jumps into the chewing state, and then once you exit, it'll go back into that empty state. So this is like basically a very simple way to set that up. And so the last thing we want to do, just kind of wrap this up here, is go ahead and just trigger that whenever fruit enters the mouth. So to do that, we're just going to use the existing scripts we have, but what we're going to do, this might be a little janky because we're short on time, is create a method here, a public method in the fruit spawn manager. This on mouth enter, and so create that method. We're also going to go ahead and get access to the mouth animator. So that's again something we're going to be setting in the inspector. And mouth animator dot we want trigger somewhere. Set trigger. There we go. We're going to set the trigger, and we called it start chewing. So what we're doing here is just like we did in Unity. We're doing this exact same thing in the script. Instead of clicking that radio button, we're just using this method here to click that radio button for us. Very simple, straightforward thing. And the only thing we need to do is whenever we actually get into the mouth, we need to call that method. And because our fruit spawn manager is an instance, we can easily just go ahead and call instance and on mouth enter. Just call that from here. Very straightforward because this is exactly when that happens. And so that'll call our mouth method here. So the only thing we have to do is drag and drop the animator we want, which is on bone 6. And save that, and let's just see what it looks like. So yeah, there you go. It's now, food's actually going in really easily, so we're gonna have to play around with the game design a bit more. But yep, as soon as it hits that mouth, it chews, closes up the collider, boom. Let's just get this into cardboard really quickly. I actually haven't been using the DK2, so I think all of the settings are set for cardboard, which is beautiful. My build settings over here. I'm just gonna call this V4, save it, get it on the phone. It's gonna be awesome. Oop, and I can't seem to put in my password. There we go. Drag our mirrored phone over here. Drink some water, stay hydrated, always important, especially when you're coding. Water makes sure that you're actively thinking. Alrighty, let's make this big, really big, and let me get this actually in cardboard so that we can see what it looks like. Yeah, and I guess as far as for you guys, I'm gonna reset us. Oop. So now I can, if I want to just troll with the fruit, actually I want to get it in my mouth. Ah! No, I can't get it. Get drunk, get out of the way. There we go. I got it. Chomp, chomp, chomp. Chomp. This is so awesome. This is so cool. Um, yeah, we're gonna have to play around with the game design a lot more. But it's, yeah, we've got basic physics working with our elephant, and we've got an animation with a bit of code, not too much, not too much. We got it done in 2 hours, which is still pretty good. But come on, come on. Yes, eat the fruit, eat the fruit. I guess carrots isn't really a fruit, but we'll go with it. Um, yeah, yeah, we're gonna have to clean up the fruit. Yeah, there's a bunch of cleanup that we need to do, but we got the basic game design and game flow working, which is so cool. Was not expecting to get through this in 2 hours, but we did. Um, and that's really awesome. So I'm gonna leave this here for this week, and I'll put links to like certain stuff that we worked on in this video down, hopefully by the end of the day. So if you guys want to reference certain parts, you'll be able to do that. If you guys have any questions, I'm gonna be sticking around probably for a couple more minutes. And yeah, next week gonna be working on probably the UI, maybe a bit more cleaning up of the fruits, but like we have the basics down. Um, Probably start looking into like let's play a sound like when he chews. Let's add a scoring GUI. Let's maybe add like a game menu at the very beginning. Stuff like that. Very probably hopefully not a lot of code there. I'm gonna try and keep that to a minimum. This week did have a fair amount of code, so I know if you've never had any experience before with Unity, it might be a bit of a shock. Um, but that's just kind of the basics of getting game design down. But yeah, yeah. So yeah, let me know. Yeah, just keep talking with us. If you want, stay tuned to what we're doing in the future. Like our Facebook page, or subscribe. Either of those work. Get a notification of when we're planning to do it next week. Hopefully around the same time. But yeah, thanks for sticking around, guys. And I think I'm gonna wrap it up here. So let's grab some stuff, and yeah, I just wanted to chat for a couple more minutes. So if you have any questions, put that in there. And that's it for me. So it's been FuseMan. I'm signing off. See you guys next week.